Okay, so the topic of this video is impossibility of oscillation. So for a given dynamical system, the governing differential equation is given like this. Okay, and for this differential equation, the solution of x has been identified. Let's say that is x of t. Okay, and the claim is, if it is a first order system, okay, which means there is only one x, in that case the oscillation is not possible for that system. So that's what the claim is. Okay, so in order to understand why it is impossible, first let's understand what is oscillation. Okay, so let's say there is a system and the solution exists for the system, and the solution is given in this manner. Okay, let's say it's given in this manner. Fine, and this is what the oscillation is, and the claim is it is not possible to have a solution in this manner. Why it is not possible? Let's say let's consider a time, some time t. Okay, let's call that t as ta. Okay, and it has some x value. Okay, the same x value is possible for some other time as well, and let's call that time as tb. Okay, fine. So at ta, what is x dot? So x dot is nothing but dx by dt, which is the slope of this curve at this particular point, right? So here, which means at t is equal to ta, the slope is positive. Okay, so that's all I need. The slope is positive. What about at tb? So tb, the slope is negative. Okay, so at one point the x dot is positive for some x, and x dot is negative for the same x, but only the time is different. Okay, and if that is possible, then for a same this is the governing differential equation. So for the same x value, we are getting two different x dot, right? And that is not possible, and that is possible only if t has been presented explicitly, but here we are considering only the autonomous system. So for autonomous system, we can't have two different x dot value for a same x value, and therefore it is impossible to have oscillation for this sort of system. Okay, so that's what I want to explain in this video. And in this book they have given a mechanical analogy, which is an overdamped system, in order to explain that it is not possible to have an oscillation. The system they have considered is a spring mass system, which is immersed in a honey, which is a highly viscous fluid, so that the inertial effect in the spring mass system is very, very small compared to the viscous effect due to this honey. Okay, and because of that the second order effects will be neglected, and the system will become a first order system, and at that time we will not have an oscillation of this mass. it will just keep on extending and it will approach to an equilibrium position. Okay, so I encourage you guys to read this topic, mechanical analogy, in this book. Okay, in our next video we will discuss the topic potentials. Fine, see you in the next video. Thank you.